Am I live? Is it? Yeah. Oh yeah, very cool. Okay, so today, 4:11:18. So what we're talking about today is rational exponents. The hardest thing about math oftentimes is, what do they mean? Put it in English, right? We know rational means fraction. And then you're thinking, why don't they just say fraction? Well, we have to be sophisticated mathematicians, so we use fancy words, okay? So we're talking about fractional exponents. So fractional exponents, what they do is they, here's your English, this is not very mathematical, they make roots, like square roots or cube roots or whatever. So fractional exponents make roots. Fractional exponents mean roots. The top number is the power, and the bottom number of the fraction is the root, okay? If it's a negative exponent, we all hopefully know that if it's a negative exponent, it's just going to be 1 over, right? It's just going to be 1 over. So if it's a negative exponent, it's just going to be 1 over, okay? All right, now, number 1, 2, and 3 can be done on the calculator, okay? It can, but I want to do it without the calculator. You could type it in and you can get the same answer, but I can get this answer faster than you can type it in, okay? Because I know that what this means is the cube root of 8 squared. Bottom number is the root, top number is the power. Okay? Bottom number is the root, top number is the power. I already know what the cube root of 8 is. That's 2, you agree? So I know that 2 squared is 4. Now, I would have done that a lot faster, and I would have beat you hands down if you typed that into a calculator, right? But the calculator will do this. But bottom number is the root, top number is the power. Cube root of 8, what times what makes 8 is obviously 2. 2 squared is 4, okay? The difference between example 1 and example 2 is just the negative. If it's a negative, it's going to be 1 over. Just going to be 1 over because of the negative exponent, okay? Let me highlight the negative exponent, okay? Here's my negative exponent, okay? Because it's a negative exponent, it's 1 over. So it's 1 over cube root of 8 squared. So instead of being 4, this one's going to just be 1/4. Because we already know the cube root of 8 is 2. 2 squared is 4, right? We just did this. That seem pretty easy? And again, yeah, you could do it on a calculator. You get 0.25, but you know, your calculator will do it. Okay, guys, you with me? Calculator will do it. So if you're in the test, you say, I don't remember what he said, grab my calculator, boom, 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 I can get it, okay? Example 3. So 1/2 power, and let's write this down. If I have x to the 1/2, it is always the same thing as square root, okay? Always. 1/2 power is always square root. And it makes sense because there's a little 2 here we never write, and there's a number 1 here we never write. So the 1/2 power makes sense. I've got a negative exponent. So the answer is 1/12. I can do it in my head, but I'll show you why. The answer's got to be 1/12 because it is the same thing as 1 over square root of 144, right? Because 1/2 power means square root. 1/2 power means square root. 1 over means the negative makes 1 over, which makes 1/12. Okay, so give me thumbs up. Does it seem easy so far? Okay, bottom number of the fraction is the root, top number is the power. If it's a negative, it's 1 over, okay? Now, example 4 is just rewrite, okay? So this, your calculator can't do this because we're going to rewrite it. We're going to rewrite this as 7 to the 2/4 power. That's the 2. It's power 2. That's it. There's my power.
7 to the 1/2 or the square root of 7.
Which would be better, 7 to the 1/2 power. And we're going to leave it that way because they want it as a power, okay? Okay. Or it could be written as the square root of 7, right? Okay, example 5. Before I do example 5, let's just look a little side note on number 5. If I have x squared times x cubed, okay, we're going back to pre-algebra, right? It'd be x to the 5th. We agree? We agree? X to the 5th? Because you added exponents. They have the same base, 10, right? The same base, x, and x. So we just get x to the 5th. Same type of problem. We're going to get 25 to the, well, what's 3/5 plus 2/5? Because we're adding exponents, right? Which is 5/5. And Jacob, you're right. You're ahead of me, right? Which is basically 25 to the 1. Again, you could do this one in your calculus. There's no x's, right? You could type it in, and you will get the answer of 25. Okay? But we can do it faster without a calculator, okay? So far, thumbs up. Okay, I like that. Turn the page. 1, 2, 3. Turn the page, okay? All right? Okay, example 8. Let's do a little side work. Something we know. If I had x to the 4th divided by x to the 3rd, we know the answer is going to be x to the 1 because you subtract exponents. They have the same base, right? So I'm really going to go 8 to the 4/3 minus 2/3, right? Just subtracting exponents, right? For the same reason, same base, subtract the exponents, which will give me 8 to the 2/3. Am I going too fast? And we've done.
What did you subtract?
Great question. Right here. What would I do here? So it's the same rule, isn't it? Same rule. So I'm just going to subtract exponents because it's divide by, right? So I get, we already know this one. This is going to be 4, right? Because it's the cube root. Sorry, cube root of 8 squared, but we already know that's 4. Because we've done that one 3 times now, right? We're getting good at that one, aren't we? Right? So then, example 7. Okay. Let's do a little side work. A little side work. You know, if you had x squared cubed. I sure can, thank you. If I have x squared cubed, hopefully you say, Mr. Davies, that's x to the 6. Because when you do an exponent to an exponent, you multiply, right? So we'll do the same thing. Let's go and make this x to the 2/9, right? And we'll do a 27 to the 2/3. All right, and this, you gotta be careful on this one, because 27 does have an exponent. We don't normally, right? It's got an exponent of 1. So I'm still just multiplying exponent. I really am multiplying exponents. I'm going that exponent times that exponent, and that exponent times that exponent, okay? Now, this is going to be the cube root of 27 squared times x to the 2/9.
How'd you get to the square root of 3?
The cube root?
Yeah.
Great question. Root power. Remember how we did this? Same thing here. Root power. So the thing, cube root, squared. Okay, same thing, Tammy. Cube root, squared, right? So I'm just doing the same thing, except for with 27, okay? Cube root of 27 is 3, right? 3 squared is 9. You okay with the 9? Cube root of 27 is 3. 3 squared is 9. X to the 2/9 power, okay? Claire might ask me, Mr. Davies, could it be written as, by the way, take this answer. Claire might say, Mr. Davies, can it be written as 9 times the 9th root of x squared? I would say yes, Claire, it could be. Which one do you like better, though?
I like the first one.
Me too. You agree? Me too. I like this answer better than this answer. Right? Yeah. Both answers are correct, okay? All right. Number 8. Real quickly, can I slide the paper up, way up, way up, way up, way up, way up? Okay. Let's put some special things up here. We have cube root of 8 is what? What's cube root of 8? 2. Cube root of 27 is what? Cube root of 64 is? Right, you see the pattern? Hopefully. What do you think I'm going to put down next? Cube root of, well, you know the answer already. It has to be 5, right? 125 is 5. You okay with that? Cube root of, I think it's 216, is 6. And what is it? Okay, do it on a count real quick. What's 7 cubed? 729? Solis, is it 729? 7 times 7 times 7? Boy, was that way off. 300. 343.
That seems right.
Yeah, it does, because, the cube root, that's what I'm glad I had to check. 343 is 7, okay? So if we have these numbers, right? Okay, got those numbers? Let's look then at number 8. Okay, cube root of 56. So I need to reduce it, like we do reduce square roots, right? So I need one of these numbers. I need one of these numbers, because I need something times something makes 56, but I need one of these numbers. Do you see anything? 56, what do you think? What times what makes 56? That has one of these numbers. Okay, what times what makes 56 that has one of these numbers? 8 and 7. 8 and 7. Now, if you don't know your times facts, I'm sorry, bummer. But how about 8 and 7, okay? So let's go the cube root of 8, cube root of 7. And then yesterday we talked about taking half the exponent, right? But today we're going to take a third of it. And we know why it's a third, because it's the same thing as a 1/3 power, right? We know that today, the same thing as a 1/3 power. So we take a third of that as x3, right? Are you with me on that? x3, take a third of that. So you just get x3. So my answer is 2, right? X cubed, cube root of 7. A little bit harder, right? Got to problem solve a little bit more. Slide it up. Okay, so before I do this one, you ready? Let's go and look right up here. Right? So if I rewrote this as x to the 10 force divided by x to the 4 force, right? I could subtract exponents, right? Which would give me an x to the 6 force, right? You okay with that? We could reduce that, can't we? We could reduce that to as x to the 3 halves. You okay with that? Why not, right? How about we change this to x to the 1 and 1/2. You okay with that?
Yeah. That's
So how about an x, and this is going to fry your mind, but hopefully not, x times the square root of x. Whoa, how did I go from x to the 1 and 1/2 to x square root of x? How'd that happen? How'd this... So Tammy's going to say, Mr. Davies, that's obvious. You got an x to the 1 right there. And we know that that's to the 1/2 power.
No, I'm not going to say that.
So if this is 1 and 1/2, it's like having an x to the 1 times an x to the 1/2, right? There's my x to the 1. And we learned that anything of the 1/2 power is a square root of x. Okay, last one. Okay, last one. Example 10. So let's break it up. First of all, the same thing as the cube root of x to the 6th over the cube root of 250. Okay, how am I doing? Does that make sense? So far, so good? I haven't done anything, really. I just broke it into 2 fractions, right? I haven't really done much at all. I just made it 2 fractions. Hopefully, you guys see what we should do on the top. What are we going to do with the numerator? The top? What do you think?
Don't you have to divide it on 5?
What are we going to get? X squared, right? You guys okay with that? Top's easy, right? Top is easy. Now, the denominator. Do you see, denominator, do you see any of these numbers in 250? Do you see any of these numbers in 250? Do you see any of these numbers in 250? You don't see any of these numbers in 250? Do you see any of these numbers in 250? You don't see any of these numbers into 250?
That's 2.5.
There we go. So, Mr. Big Candy says, how about we do the cube root of 125 times the cube root of 2? You okay with that? Yep. All right, let's see what we got. We're going to have an x squared over 5 times the cube root of 2. Okay? All right, now, how many 2's do I need down here to get rid of it? How many 2's do I need down here to get rid of it? It's a cube root, right? I've got 1. How many 2's do I have to get down? So I need another 2 2's, right? So I'm going to multiply by cube root of 2 squared over cube root of 2 squared, okay? Let's see how that helps.
Mr. Davies, I have a question.
Yes.
Couldn't you just write cube root of 4?
Yes. Yes. Smarty pants. Yes. So then what do I have? Well, hopefully you guys can see this becomes 2. I'm running out of room. Do you see how that would be 2? Because you're going to get 2 to the 3rd power, right? Cube root of that is going to be 2, right? Or like Katie said, 4, right? 2 times 4 is 8. Cube root of 8 is 2. So let's finish this up. I'm running out of room. So in the bottom I have a 2 times 5 is 10. Okay, where did the 10 come from? Real quick. That's going to give me a cube root of 8. Cube root of 8 is 2 times 5 is 10. And on the top we'll have an x squared cube root of... Katie, let's put 4 like you said. Let's put 4 like you said. How about it? Right? So we have a wee bit of homework to do, but we've got 15 minutes to do some